Hi guys, good morning.
Good morning.
We'll wait for 1 minute and then we'll start the session.
Okay.
So I think we'll start with the session today. So guys, today I'm going to explain about the EMR in AWS. So in the last class we have seen how to create a normal EC2 environment in AWS, how to spin up a EC2 machine. Similarly, we can like I told in the previous session, there is another feature available in AWS that is an exclusive environment for the big data processing coming from AWS side. So it is an enterprise version of big data from AWS, which is called as EMR or Elastic MapReduce. So there is no don't confuse with any MapReduce program. It is nothing related to MapReduce programming model, anything. So their service name is known as EMR, Elastic MapReduce. So Elastic MapReduce give a lot of services, big data service, all the big data services what we get from Hadoop, Spark, and other related to Hadoop, Spark, and Hadoop related components like Hive, Peak, Scoop, Flume. All those things are incorporated and integrated within a single suite. That is what is called EMR. So once you start a EMR cluster and start using it, you will be having access to all these services in this particular cluster environment.
Sir, screen share ചെയ്തിട്ടുണ്ടോ?
Not yet started. I'm going to share the screen. Okay. Hope you can see the screen now. It is AWS management console. So just to introduce, so this is the AWS management console. If you don't know that particular name, this is what is called AWS management console. So here in the services, last time we have selected EC2 from the computing section. The storage we have S3, and the database we have many database services available. And like that, there are many around more than 130 services are available from AWS. So I'm not going to explain all those things here. We will quickly jump into EMR. This comes inside the analytics part. So we'll click on EMR. So before going to this EMR, I'll just show a small explanation about S3. S3 is actually a data storage system within AWS. S3 stands for Simple Storage Service. So in S3, we can create a bucket. So bucket is something that is a universal name, a unique name identified to identify the your source of data. Here we can create as many buckets we want. So storing data in bucket is free actually. There is no charge associated. Only the retrieving of data will have some very minimal charge. So it will not, we don't even know anything to consider that is a charge actually. Very small. You can create as many buckets and store data. When I took training, in case if you are not able to hear, just let me know. Okay, if you are facing any issue. Okay. So I have created some buckets as part of the training here. So let's have a look at some trainings here, some buckets created. So this bucket has got some data. So I push some data into this bucket. This is a bucket Luminar Labs. So if you go to this bucket, this is a public bucket because it's showing permission as public. Okay. And if you click on this, any of this data, it will show a URL, object URL. So if you click on this data, it will download the file if it is a public. If it is not a public, if it is a private, you will not have access to this particular data because this is a public URL, right? So anybody can access using this. So if you are not given access, you will not be able to read data. And then we have this property here. Here property, we have mentioned a lot of things here. We will explain that in detail later. And here I am giving the permission and everything, public access and everything. Currently, it has got public access to everyone. So everybody can read the data. So currently there is no compression applied. File format is CSV delimited data. So this is about the data you can click on and download. Currently it is already public, so I don't need to make it public. I can remove the public permission, so you will not be able to access the data using the URL. You can download from here anyway. So that is all about a file inside this particular bucket. And if you click on this, so how you are going to access a particular file in bucket, it will be like, so here, for example, this is a bucket, okay. And inside bucket, I have multiple folders. I can go to source. So there is a folder. Here itself, inside there are many folders, JSON files. So if you click on all these things, how you will get the access to this actually, S3 path will be like S3 colon double slash, then that particular full path, source slash JSON slash chain.json. That will be the path of that particular S3. This is how you are going to access the file from any program you are going to write, whether Python or PySpark or Spark, Scala Spark, whatever. So just a small introduction about S3. There are a lot of things to explain about S3, but I'm not going to explain and go on with that. We'll quickly go to EMR and we'll see how to spin up a cluster. So let's go to EMR. So this is a welcome page for Amazon Elastic MapReduce. Here we have an option to create a cluster. Currently it is showing you don't appear to have any cluster. So you can create a one. So once you create a cluster, you can upload your data and processing application from S3. You can configure a cluster by specifying the input and output, then execute it and do the monitoring. So all these are available for you. So if you click on cluster, create cluster, there are some configuration you can take. So I'll go to more advanced options. So you have so much freedom to select the components, whatever you want. So this is the latest version is 6.00, or previous release versions are 5.3, 5.29, 5.2, like that it goes. Last time when I was using 5.20 version. So anyway, I will just click on this and let's see how it works. So in software configuration, below that, you can select what all services you required for your big data processing. Do you need Hadoop? Do you need Hive, Q, whatever, Spark, Jupyter Hub, Zeppelin? Zeppelin is a virtual, is a interactive notebook type environment like Jupyter Notebook. Then HBase, Presto, Scoop. There are many services, Flink, Livy, Big, Zookeeper. So whatever you need, you can select from this. I will uncheck this. Then I will click on what is required only. You can select Hadoop, you can select Hive, you can select Hue, Spark 2.4.5, then Jupyter Hub, Zeppelin. I am selecting only this much for now. Use multiple master nodes to improve cluster availability. So to provide high availability, you can use multiple master node. For that, I am not, for time being, I am just not using it. In case if you are using a production version of the environment, you need to ensure that you will have multiple master nodes. So in case if one master is down, you can switch over to the another master. So it will automatically switch over to the another master. You don't need to manually configure it. And AWS Glue data catalog setting. So AWS Glue is a kind of a it is an ETL framework in within AWS. It also acts as a catalog management. So catalog management in the sense when you configure a Hive environment, how you will be installing. Maybe you would have installed a MySQL database. You know that, right? When you use a Hive environment, the data stored in HDFS. But the metadata of the Hive table is actually stored in RDBMS, like MySQL or Demo. So instead of that, Amazon provides the ability to store the metadata in AWS Glue. So you can select if you want to use AWS Glue to store the metadata for Hive and Spark. So the advantages using any Glue is actually it is more convenient and optimized. In case if you need to shut down your EMR and restart, so you don't need to create a backup of the existing metadata and all. It's not required because Glue is already available separately. So you don't need to uh, create a backup whenever you want to restart a EMR cluster. And add in software settings, enter configuration. So this is only if you want to, suppose for example, so when you configure this cluster, you have an option. If you want to configure some software information and anything, properties and anything, so that will be executing as part of the create cluster execution. And steps are optional. A step is a unit of work to submit to the cluster. For example, if you want to run this cluster as a step by step, that is, give some steps of execution. So the cluster will start and do execution of step one by one, and then automatically it will terminate. After last step completes, you can either cluster can enter waiting state or cluster automatically auto terminates. So for time for me, I don't need this actually. You can provide a streaming program or a high program, big program, Spark application, whatever. So my aim here is to just to introduce a create a cluster and see how that works. So I'm not doing anything here. So I can go to the next. So just ensure that we have configured all this services here. So I know I'm going to get access to all this environment once the Spark cluster is available. So I click on next. Hardware configuration. So here, if you want to provide your hardware configuration. So you can mention the configuration of master, core node, and task node separately. That is called instance fleet. What is the capacity you required, and otherwise you can use a uniform instance group. So below that we have an option to select what all. So this network, I am just selecting as it is. I am not changing. Okay, network and easy to submit. This is network configuration information. So I will I don't want to confuse you by explaining all those things. So what we are going to here is I need to configure my hardware. I mean, how many number of nodes and how much memory required, what kind of configuration I need to provide. That is what I'm going to do here. So let's say one master node and let's say two core nodes. We'll keep as it is, one master node and two core nodes. Purchasing option on demand. So M5X large is by default coming here. So I need to see what is the pricing option for M5X large. So instead of M5X large, I will just for time being, I will give M4X large. Okay. Here also I'm keeping. For core nodes, I will keep M4 large only. And this also M4 large I will keep. And for master node, I will keep M4X. Okay. So master node will have 8 core, 16 GB RAM, media storage, sorry, 16 GB RAM, and media storage is 64 GB. And for core, 2 core nodes will be there. So totally we will have 3 nodes cluster. For each core node, we will have 4 cores and 8 GB RAM, and media storage will be 32 GB. So if you want to check the pricing option, 0.0210 per instance hour, and this is 0.0105 per instance per hour. So it will be 0.1 approximately $0.1 per hour. It looks like 7 something, 7 rupees per hour, 7.5 rupees. But this is a bit more. costliest $0.2 per hour. So just for understanding purpose and training purpose, this won't take much time. If you just use it, spin it for 2 hours or 3 hours, might be maximum you will spend around 30 to 40 rupees. So just wanted to introduce all this. If you want to select a level configuration, you can choose that. So it will be 0.105. Otherwise, there are some other options also. C for large, which is even lesser. So C for large is something like 0.10. So for time being, I am just going back to M4X. Okay. So configuration is done. Then root device volume for EBS. Root device means the master node where we are actually going to install and the application is getting installed. So for time being, I just keep as it is. I'm not enabling cluster scaling. Cluster scaling means it will automatically scale according to the data volume, the performance it will improve because it will automatically scale up and down according to the when you have too much processor running. So it will not get go to a waiting state. Instead of that, it will automatically scale up and down. So how it is going up and down is depending on the CPU utilization and memory utilization. So when your CPU and memory utilization go about as threshold value, let's say 75%. So once CPU utilization and memory utilization goes above 75%, it automatically add one more node to the existing cluster. And if the CPU utilization goes beyond, let's say for example 30%, that we can need to configure, right? Okay, 30 and 75 is not a hard-coded value; it is configurable. So suppose if it is goes beyond less than 30% utilization, then we don't need that extra nodes. So we can remove that node. And again, if it is going beyond 30, below that 30, again it will reduce one node. So that is how this auto scaling feature is working. For now, I am not enabling that. It's not required for us. I'm going to the next. The cluster name, I'm just giving. I just give a name, Lugnar Spark Training. Tags is not required. Additional operation options are not required for now. Next. Easy to keep pair. The key pair I have already have. I will use that. Authentication and encryption I will keep as it is for now. I am not adding any. Create cluster. So create cluster for EMR is not like EC2. It will take around 10 to 15 minutes because it need to start the 3 nodes and you need to configure, you need to install all these applications, HiQ, Spark, Jupyter Hub, Zeppelin. And once it is over, it will take 10 to 15 minutes. So by that time only, you will get all the IP address, host name, application links, UI, Spark UI, URL, and everything. Then only it will you will get it. So by default here termination protection is on. So what is termination protection is? You will not be able to directly terminate the cluster because it will actually saving you from well, something like in case if suppose if somebody accidentally you are going to terminate. So it will not allow you to terminate directly from this option, from this menu. So first of all, you have to disable termination protection, then only you can terminate it. So it will actually avoiding the accidental termination. So in case if you want to switch off that first feature, you can just off, then fine. So now it is starting. So host name is already came. EC2, the IP address, IP South 1. This is the host name. And you can connect to this master using SSH as a feature. So you can use this. So suppose if you are using Windows, this is the instruction you need to follow. Download putty, start putty. Then in the host name field, type this Hadoop at EC2 this URL. Then in the category list, connection SSH and authentication. നമ്മൾ ഓൾറെഡി ക്രിയേറ്റ് ചെയ്ത് വെച്ച PPK ഇവിടെ അപ്ലോഡ് ചെയ്യുക, റൈറ്റ് ചെയ്യുക, then click on open, it will connect to your machine. ഇനി അതല്ല നിങ്ങൾ ലിനക്സ് ഓർ ഉബുണ്ടു ആണ് യൂസ് ചെയ്യുന്നതെങ്കിൽ യൂസ് ടെർമിനൽ, ഓപ്പൺ ടെർമിനൽ, then connect to master node using SSH. So how SSH space -i, then give your path to this PM file in your machine, then give your user at ec2.amazon.aws.com, and then enter. You will be connected to the machine. So let's see how whether we can connect to from this using putty. So launch putty. For the time being, I'm just saying it here, the host name. So you'll not need to type it again. Let me save a session here. Okay. So once you give the URL here, go to authentication and upload your private key, whatever you have saved yesterday, saved for yesterday. You click on open. Click on yes. You connected to EMR's machine, EMR cluster. So this is your EMR home directory. You can just check your home. This is a home Hadoop. The username is Hadoop here. So if you will go back to the console again, it is still getting started. It's not completely started. It will take some time to configure all the applications. So if you try to connect to Hive, or if you connect to Spark, for the time being it might not work because all metadata configuration and everything is not completely started. So if you just type Hadoop Hive, it might connect, might might not be able to create a table and all because configuration is still going on. Let's see whether you can create a table here or not. I'm not able to create because it's failing, because unable to instantiate the metadata. The metadata is still not ready. It will take some time to get it configured. So that is why I'm getting this error. So once it is completely available, it will show it is running instead of starting. It might take 10 to 15 minutes usually to configure. So once it is or everything is available, you will have access to the Zeppelin notebook, Jupyter notebook, Hue, Spark UI. All those links will be visible here. So you can directly connect to that URL and then see. So on cluster application status, for Hue, this is the URL. For Spark history server, this is the URL. For Jupyter Hub, this is the URL. Zeppelin, this is the URL. For resource manager, Yarn, this is the URL. Currently, it is not yet ready. So just understand, this is the URL. This is the port number for Hue, port number for Spark history server, Jupyter notebook, Zeppelin. resource manager. And 4040 is a for Spark UI. 404 is a port number. Hope you already know that. And if you go to monitor, it will show the current performance of the existing cluster. How many nodes? What is the node status? Core nodes, task node, master node. Then cluster status will be here. Is it idle or how much container allocated? How much container pending? How much apps completed, failed, apps killed, pending, running, or apps submitted? All this information will be available. A graph will show here at that time. Then this is the hardware information. 2 core nodes and 1 master node. So this is still getting started. So once it's changed the status to from starting to running, you will have access to all the services like Hive and Spark. You can connect to PySpark or Spark Shell, or you can launch the notebook, Jupyter notebook. You can launch the Zeppelin. You can launch Hue. All the services will be available. Here you have an option of adding the Git repository also in this particular EMR. If you want to connect to the EMR from connect to the Git from EMR, you can provide the Git repository access credentials and then add the repository. Security configurations. Okay. So meanwhile, it's getting started. In case if you have any questions or doubts, you can just shoot it now. Related to this setting up Amazon account, creating a EC2 machine, spinning up EC2 machine, or related to this EMR or whatever. If you have any questions, you can just.
Sir, actually, the paid ആണ്.
Sorry.
Paid ആണോ ഇത് free ആണോ അതോ
EC2 service is free for you, but this EMR is having. I showed you right for example, if you are taking M4 large node. അപ്പോൾ നമ്മുടെ കയ്യിൽ we have 3 node cluster ആണ് ഇപ്പോൾ spin up ചെയ്തിരിക്കുന്നത്. So it is M4 large ആണെങ്കിൽ the charge is actually $0.1. $0.1 per instance per hour. So we have close to so it will be something like $7. $0.1 റേറ്റ് പറയുന്നത് ഏകദേശം ആ ഒരു എമൗണ്ട് അല്ലേ. ഓക്കെ, അപ്പോൾ ഒരു അവറിലെ ചാർജ് ആണ് ഈ പറയുന്നത് $7. If you are using for 10 hours, maybe around 7 rupees. That is the amount you need to pay. The pay എന്ന് പറയുമ്പോൾ monthly. If you have an Amazon account, there will be if you are using some paid services, a monthly bill will be generated. Okay, so we'll get an email. You can go to your billing dashboard. So in billing dashboard, it will show how much you consume. You can check monitor every month. So this is my charge. So currently as per the usage. So ഇതിൽ യൂസ് എന്ന് കാണിക്കുന്നത് എക്സാക്ട്ലി EC2 ആണ് ഞാനപ്പോൾ യൂസ് ചെയ്തിരിക്കുന്നത് $0.46. This $0.46 is mainly on the EMR services. I have used this. So a bill will be generated here, something like this. So it's showing now fully green. Its status is now waiting cluster ready. So it will change the waiting status to running. So once that is come, we will have an you will get the URL access to all these applications. I think it's already available. I think there is some change in the interface they are using. Now let me connect to this. So this is a Hue environment for this particular EMR. Okay, so you can type your username. Sorry, not open to. It is in Hadoop. We can create an account here. So you can provide the password. You can, and then you can log into this. Okay, so when you log in first time, this is what you are going to get. So this is a Hue environment. Okay, so in Hue, it is like a user interface to your repositories like HDFS, Hive, and everything, or Impala table. So you have access to MySQL, SQLite, Postgres, Spark SQL, Hive. So you can write your Hive queries here. You can create a database. You can create new database. You can create new table. You can execute the queries and everything. Instead of connecting from the here, it is like a you will get a graphical UI based environment for your Hive and other SQL based tools and files, HDFS file system. You can upload file, you can browse the file, you can read the data and everything. Access to S3. So all my S3 location files are I can see here. I show you here, right? The same thing I can see the data because on the same account only I created all the CMR. So I can browse S3. Database tables, nothing as of now. Jobs, no jobs are running currently. And documents. Local machine if you have anything, that's all. So this is Hive. You can connect to Hive. Otherwise, you can come to Spark SQL. Here, this is a OC editor. So you can create a workflow. Workflow is something like you need to create a job. I mean, you need to run some workflow like for on daily basis at a particular time. You need to run one Hive job, then you need to run one Spark job, then you need to run one Python program one by one, or you can create a workflow here and you can schedule it. So on timely basis, on daily basis, you'll start running that particular jobs. I will give you a demo on this later. So this is today. I will not have time anyway. So 10 now. So 10 by 10:15, I'm closing the session. Okay. So I just wanted to give some access to all this editor for today. And tomorrow I will show some hands-on with some programs in Hue, Uzi, and then Spark notebooks. So like this Spark history server, you have access to all this applications which is already in the Spark history. And let's see, let me connect to 4040. I don't know the port number here which they are using. Okay. Then Jupyter Hub. You want to come to Jupyter. Go to advanced. Then proceed to EC2 machine. So the username actually, the username is Hadoop. Let me just browse. I forgot that name actually. EMR Jupyter notebook login. So there is some default name is actually. Yeah, this is the name. Jupyter. So we can sign in to the Jupyter Hub. So you can create a Spark page. And you can write the program here. So all the execution happens on the MR. Similarly, you can start Zeppelin. There is also like a notebook type environment for your. You can create a new notebook. You can use Spark, PySpark, or whatever. Create. You can write your code here. You can execute. You can view the data in a graphical format. So yeah, I will show you some examples using Jupyter Notebook and Zeppelin and Hue tomorrow. How to you can work with this. So I'm creating a smart session here. You can work on this. Click on Spark UI. I need to see this Spark UI. How can I enable? Because I think I might need a incognito mode or private mode to connect to the Spark UI. Otherwise, you'll not be able to see the UI here from a remote machine. That is what happening here. So anyway, I am stopping for today. It's already getting close to 10:50. So the recording is available for this today's session. You can go and see that. Anyway, I'm stopping this particular EMR cluster for now because unnecessarily it will run for long, and I don't want to run it for long. So tomorrow I can start again and will show some few examples, and so it will help you to work with this particular environment. It has all the features, and it is actually purely an enterprise version. So that is why it is not a free thing for you. But the advantage is actually if you have everything is configured from the backend, and you don't need to work on the configuring and everything. You can start using it. All the features are available. You can have a lot of notebooks environment, integrated IDE environment, everything in queue, and all those things are available. So when you really work with some Spark environment in a production environment in a particular project, you will have to use all these things services. If you simply use a single machine and start working on uh, a terminal or a shell, it won't help you actually to grow. So that is why I just wanted to introduce all this notebooks environment and everything. So that will be a big experience for you. That is why I just wanted to explain all these things. So for today I'm closing this session. We'll meet tomorrow. And I will continue with this for some more time. Tomorrow also I will continue and I will explain some programs to connect to S3 and write some PySpark programs. And also I'll give some example on the scheduler. Okay, thank you.